Hello, thanks for attending this presentation about structural steel, concrete and rebar modeling and detailing with ProStructures. My name is Jeremy. I'm the product manager for ProStructures, which is ProSteel and ProConcrete, which I would like to show you today. My presentation will start with a PowerPoint and then we will jump into a live demo. Let's start with some basics. So what is ProStructures? ProStructures is a bundle of ProSteel and ProConcrete. Let me explain what ProSteel is first. ProSteel is a structural steel modeling and detailing application based on AutoCAD and MicroStation. Let me show you a couple of projects done with ProSteel. The first project I would like to show you is a $253 million Gippsland water factory in Victoria, Australia. It provides a sustainable solution for treating up to 35 million liters per day of domestic and industrial wastewater. This facility generates high-quality recycled water to save about 3 billion liters of fresh water each year. The project team used AutoPlan and ProSteel to deliver the project on time and on budget. The site was divided into 65 3D models that could be brought into a single view. The solutions enabled efficient drafting and engineering, construction procurement, 3D visualization and clash detection, and as-built model delivery for life cycle maintenance. The second project is a $630 million crushing plant in Western Australia. T&G performed engineering design for steel, concrete, mechanical, electrical, ducting, structural and civil works. T&G streamlined the workflow by directly linking a 3D model to 2D drawings for design, review, and production of 2D shop detail drawings for construction, which occurred concurrently. ProSteel was T&G's primary software. Working with a 3D model enabled T&G to visualize and communicate design concepts and perform clash detection. ProSteel integrated seamlessly with other software, enabling T&G to add value for Fortescue Metal Group. Modeling in 3D saved an estimated 30% in time compared to designing in 2D, with an overall cost saving of about 20%. So what is ProConcrete? ProConcrete is a 3D modeling and detailing solution based on MicroStation or AutoCAD. Well, you've heard that before. It's the same like ProSteel, but for concrete and rebar modeling and detailing. ProConcrete is suitable for any kind of projects like bridges, buildings, foundations. And if I say any kind of project, I mean that. There are virtually no limitations to concrete and rebar modeling. Both applications, ProSteel and ProConcrete, will run in the same session, so it's a very tight integration. The base of the objects are the same, so if it is possible, an example, to determine any collision between all objects, the look and feel of both solutions are the same and they are using the same tools where it makes sense. An example, both of them are using the same commands to create material lists or to create the 2D drawings. The idea of ProStructures is to create a complete 3D model and create all desired 2D documents out of it. We provide not only open databases for standard shapes. Anything that you can define by a closed line can be an object in ProStructures, and it is almost as easy to create them. This includes plate work, including bending and unfolding of plates. ProStructures comes with a lot of standard and non-standard connections, which provides the possibility to create those joints in a heartbeat. This includes tools for complete stairs, handrails, ladders, trusses, joists, purlins, portal frames, catwalks, platforms, circular platforms, and so on and so on. ProSteel is maybe the most flexible, powerful, and easiest to use 3D modeling system on the market. But if there is something not out of the box, if you can draw lines, you can create the 3D model. But not even that. Let's assume there are other solutions out there, something like Autodesk Inventor, ProEngineer, SolidWorks, CATIA. Here an example of an Inventor project. We just open these objects in ProStructures, add some information, and you can use them in your project. not even for clash detection, even to create bill of material or even 2D drawings. Again, there are no limitations. Here another customer example. In addition to ProStructures, some mechanical objects have been used to create a complete 3D model and later to see them on the 2D drawings. Since we are talking about the output from the 3D model, ProStructures can create automatically NC files according to DSTV and DXF files for plates, and we even have a direct interface to solutions from ASA to support all the available downstream rebar applications. To create a bill of material, ProStructures doesn't only create a Microsoft Access database, there's a form generator implemented to create and easy to customize lists fully automatically. This includes building bar schedules, including schematics and scaled pictures. Again, everything is open. This includes the export to any ERP or PPS system. 2D drawings will be created almost 100% automatically as well. Dimensions, position flags, bill of material, and so on. And you said everything is fully customizable. Even line styles, line weights, text styles, layers, you name it. If I say automatically, stuff like this is easy to create in ProStructures. Only when it is a little bit more complicated, the power of the major platform makes it possible to create any kind of 2D drawings. In this case, the section or view has been created automatically, annotation has been placed manually. Just to mention, not a surprise, if you create 2D drawings and if there is a modification in the 3D model, all 2 documents will be updated automatically. Have I mentioned that ProStructures is based on a standard platform? The beauty of that is that it is so easy to work with other solutions, an example plant, HVAC, AEC, whatever. There are no interfaces necessary to combine multiple discipline projects for clash detection and the 2D documentation, like you've seen in the beginning of this presentation. Before I start, I want to mention that everything that you see today will work on AutoCAD and MicroStation the same way, but I'm working on MicroStation. The first thing I want to do is I want to insert a grid. And since we are working in a 3D environment, I want to have a 3D grid. If I do any modifications in the dialog boxes, the model will be updated automatically. My grid could be rectangular, cylindrical, wedges, pyramids. There are almost no limitations. You can define even your own grid, so everything is possible. If you have done any modifications, what you can do, you can go in here and you can save these settings, give it a name, and you can recall them later on. So you can switch between all these settings. Next step I want to do, I want to insert some shapes. I want to create some columns. I could insert them by existing lines, could be any kind of line, between points. But I just want to say I want to have my columns anywhere in this area. Well, that was easy. The next step, what I want to do, I want to insert some beams. I want to have my beams at this level, using the same command again. I want to have beams, and you would see that my insertion X is now top of steel, and I want to insert my beams in this area. I want to do that again, but at this height. So done. Just move back my coordinate system to the bottom. I want to change my view a little bit, and let's say I want to work in any other mode. It could be monochrome, it could be shaded. In this case I want to work smooth with shadows. I can even lighten it up a little bit, something like that. Beautiful. So next step, what I want to do is I want to insert some base plates. Let's start at the bottom with different connections to implement into ProStructures. We've seen a small list in the PowerPoint presentation in the beginning. So let's keep it simple. I want to have a basic base plate. I can zoom in a little bit and you can see that I can define the size, the holes, how I want to connect them, the welds, if I want to have anchors and dowels. Let's keep it simple in the beginning. If I like that, I want to clone this base plate to some other columns at the same time, so that will save a lot of time. So this was now a really simple base plate. Let's create a little bit more complex one over here just to show you what is possible. I want to have a base plate over here. So I could define, of course, the sizes, how I want to connect them. I could have dowels, flanges, corner plates, inner plates. Switch those off maybe. If you do a modification, you see that will be updated automatically, and so on and so on. The other connections, to save some time, I do that with our AutoConnect command. AutoConnect is, you can say, kind of spreadsheet where you can define columns and beams and girders, and if a specific size is connecting to a different size, it will insert automatically the connections. In the meantime, I want to show you some connections like what we have implemented. We have the standard end plates, of course, base plates like the standard base plate, or even more complex, even for circular shapes, spliced connections, different bracing connections, static bracing, and even more complex connections, including wraparound and so on and so on. There are hundreds of connections included, and the list will grow with each release of our software. So my connections are done, and if I have a closer look, here are my end plate connections done automatically. If I go in here and I want to insert another connection manually, again it could be anything, but keep it simple for today. I want to insert a web angle connection between this beam and this column. And again, if you go in here, and for instance you want to change the number of bolts or the sizes or distances, everything that you do here will be shown in the 3D model automatically. So if I go over here, I want to switch my view to show you what's going on a little bit better. I'm here at this column, and I want to insert the same connection between this beam and this column. So this connection has now been inserted. If I want to do the same and from the other side, it determines automatically that there are existing bolts and it will replace the existing one with the one that fits. If I want to save some time, what I can do, I can even clone my connections. It's a kind of copy where I can say I want to have that between all of these objects. And it will create all these connections automatically. Next step, I want to insert some bracings. We have this 3D grid here, and this is not only lines. What we have done here, we have created some views. So I want to go to the first view and say here in this area I want to insert a bracing. So these views will rotate to the correct view. It will set my ECS, UCS, so I'm working on the correct plane. I want to have a bracing just anywhere here in this area between this column and this column. And here's my bracing. Let's have a closer look. I can define angle bracing. I can define maybe rod bracing, pipe bracings, and you can define everything. The shapes, the bolts, the gusset plates, fully customizable. Okay. I want to go now to another axis. I want to go to the next frame. And what you see now is it has switched off all other objects which are outside of my area. So I have a bracing in the first frame, but I'm working in the second frame or second axis, and I want to see only what is in this area. So that makes it much easier for me to work. I want to have another bracing between these 2 points, between this column and this column. And let's say I want to have a pipe bracing, just to see the difference at the end. Let's go back to an isometric view. And the next thing I want to do, I want to insert some purlins. I want to have my purlins between this point and this point. So I can define the shapes, the angle, how they overlap. Well, in this case, I want to have them maybe change the distance, and you see that the number of purlins will be updated automatically. Now I want to connect them. Connections, I want to insert them. Just select here my girders and my beams. Do that again on the other side. Beautiful. Oh, I like that. Let's say that's enough for my steel work. What I want to do,
I want to take these objects and put them into something we call a display class, and let's say that's my steel part. I select my objects. What I can do in here now, I can just switch them on and switch them off. Okay, let's have a look at ProConcrete now. I could do the same stuff what I've done in ProSteel to insert columns, beams, and all the other objects. In this case, I just want to insert some concrete objects which have been created in any other application. It could be RAM, StatX, StatPro, whatever. What I'm using here is now ISM, Integrated Structural Modeling, which is our solution to exchange projects between all our applications, which includes even non-Bentley applications like Tekla Structures or Blueball, or even Revit. And this includes not only steel and concrete, it includes rebar as well. So I have here now some columns, some beams, I have a slab, I have a few panels. I want to show you how easy it is to define these concrete objects. So I go to ProConcrete, and you see that I didn't leave the software. I'm working still in the same session, so I can work with concrete and steel at the same time. I want to insert a pad footing, and I want to have it for this column. That was easy. And I want to have a continuous footing. Between this point and this point. So that was easy. Let's put some rebar in there. Let's start with the columns. I have here again some predefined settings, and I select one of my columns. I can define the bar quantities. I can even define the vertical rebar, individual, and I can have different ties. If we have a closer look, this is how it's looking like, and on the top I even have a different spacing. If I change the setting, something like that, I can even have mechanical couplers. But I want to keep it simple at the moment. If I like that, again, I can clone those to my other columns. Oops, missed one. Okay. Now I can define the rebar for my pad footings. Select it, and I can select the column as well to get my dowel's done. Next one, here's my column, and so on, and so on. So that will do. From a continuous footing, I can select my concrete. Let's do it here as well. And if we have a closer look, the continuous footing knows that I have a stock length and a mill length, and I have some lap information. And at that moment, if the rebar becomes too long, it will automatically splice the rebar. I want to go in here now, and I want to hide everything except my beams. That makes it a little bit easier to show you how we can put rebar into my beams. It's almost the same to put rebar into the beams like we have done for the columns. Select my predefined settings, and here's my cage, and you can see that I have different zones at each side. I want to do the same over here, and you would see it's a parametrical object, so it doesn't matter how the beam is looking like, everything will be adjusted to it. Here in the front I want to do it a little bit different. Let's say I have some settings for this beam, and here I define, let's close that, different ties. You see that the beams have different length, and so on and so on. And I want to have something from the other side. That would be here. So that would be looking a little bit different. But in this case, my rebar goes to the wrong direction. I can easily fix that. I go to the concrete object and say I just want to flip it. That's looking much better. Beautiful. I like that. And I'll switch on all our other objects. And let's have a look at my panels or walls. I isolate those. And sometimes in 3D it's tricky to orientate and to work in 3D, to get the right view to objects and set the ECS, UCS, and so on and so on. And ProStructures is very easy. In this case, I just go in here and say, I want to have a look at this object from this side, and everything will be set automatically. And now I can go in here and I can draw, for instance, just a rectangular object. It could be anything, or in this case I just want to have an opening anywhere in this area. And now I can use this standard line to punch a hole into my wall. I don't even need this line anymore. Or maybe do it another time, just a little bit different. Just I want to have, for instance, a circular opening in this area. I'm using the same command again. Oops, missed the circle. That's better. Okay, now let's put some rebar in there. Going to my wall reinforcement. Select my concrete. Select the other one. And you would see that the ProConcrete determines the openings and replace the rebar accordingly to it. For the openings, I could add some trimmer bars. Just select it. Have a closer look. I could have perpendicular U-bars. I could even define different lengths for each side. Well, let's keep it with 2. I could have parallel and corner bars. And of course I can define the size, quantity, spacing, whatever. Let's switch on all the other objects again. And let's say that's not too bad. And the last thing I want to model here is something which is kind of not out of the box. So I go to my slab and to my column, these 2 beams. Isolate those. And I want to insert a little bit more complex object, like this one. I want to insert it here at this point. Oh, I have to move it a little bit back. Select it, and I want to move it from here to there. You see now it's refreshed, and here is my beautiful object. Oops, I've missed here some lines. I want to move those from here to here as well. So I need these lines to show you something more complex. So I could use my rebar command and do that in a moment to put my rebar in here. But what about something when it's round and a non-rectangular shape? I go in here and say I want to insert, it's called irregular dispatch. So this would be my concrete object. And I can define spacings and all that stuff. And now I'm selecting these lines and it will place a rebar between those standard lines. So everything, so just say you create anywhere in 3D space your lines, and the rebar can be placed between those. In this case, since I have a circular form, I can even go in and say make arc segments out of that. And I can do it even here in star form around this opening if I would like to, but I leave that at the moment. Let's go back to my wall reinforcement command. And select my wall. And we are done. I like that. Let's say that's enough. Switch on my steel. So what's the beauty now of working with ProStructures? I can go in here now to this column, and I could say I want to create a pad footing at this point. And now I can go in here and ProSteel and say I want to insert some anchor bolts. Just selecting my plate. Show the direction. And here my anchor bolts. So I can really work in one environment with steel and concrete. And that's not even all. What I want to do now is I want to go in here, in here, and I want to insert a reference. I want to attach one. Okay. I want to extend the dialog here a little bit, and the X offset is -165, and the Y offset is -57. And the Z is -13.5. Okay. So now I don't even know where this is coming from. It could be HVAC, it could be from any plant application. I really have no idea about that. But what I can do is now I can do a clash detection between all these objects. I want to create a new job, and let's say plant versus my steel, where I say my reference model, and I see that here this would be one part of the objects, and I want to check those against my steel shapes. So now what we'll find here now that this pipe has a collision with my column. So I can go in here now and make a cutout like I've done in the walls, or I can move the pipe, whatever is easier. But I can determine those during the modeling, and I can avoid these problems in the future. That makes it easier to have the correct and workable model. I want to go back to my references and just switch it off. Let's say that's enough for 3D modeling. There's a lot of stuff to show you, but just a lack of time. You can have you can attend other e-seminars or request some more detailed information and presentation from any of my colleagues. The next step I want to create some to-do documentation. Before I do that, I want to run something we call a positioning. We just compare each of the steel objects in this case, and if they are the same, they get the same position number. If they are not the same, they get a unique number. I can define all these settings, like stuff like if I have two steel shapes and the length difference is just 1 millimeter or 1/8 of an inch, do I consider them the same or not? I can compare single objects. I could have assemblies or groups, and all of that will be taken into account. In this case, I have 308 steel objects and 35 different position numbers. And ProSteel has created 16 groups or 9 different groups and some connections. If I want to do that the same way for concrete, it's a little bit different because of the rebar. I can say that I want to assign a bar mark number to the rebar. To do that, I have to select my standard. In this case, is ACI, but it could be Swedish, could be Eurocode, South Africa, Brazil, whatever. I can decide if straight rebar should get a bar mark or not. In this case, I don't want to do that. And now I have a look at all the concrete and the rebar. So these are my concrete objects. These are my cages. And these are my single rebar. If we have a look at shape type number 2 and select that, so that would be a type number 2 according to ACI code. I would get the schematic picture including the length information and the scale picture. If I don't like that for any reason, I could go in here and change that, for instance, to a number 17. And you see now it's a number 17. If I go down here, here's the type number 9. That would be my circular rebar. T6, my T2, and so on and so on. When I've done that, I can create bill of materials or bending bar schedule. So for ProSteel, I can create a database. Let's call it for steel. And this is an Access database. I could use Microsoft Access to create any forms and create the bill of material. But again, we have a form generator included, which makes it much easier. Let's say I want to have a single part list. Take one of the forms. I can create those lists in any kind of format like PDF, XML, Excel, whatever. Let's create a preview. And here's my bill of material. Let's have a closer look. So I have my group parts, single parts. I can have a summary at the end about weight information, length information. If I select a different form, it will look like a little bit different. So, and again, all of that is fully customizable. Let's close that and do the same for concrete schedule. But in this case, it's not only creating the Access database, it's also creating all the bitmaps for the bending bar schedule. So let's select a different type of list. Let's create a preview again. So here's my schedule, zoom in a little bit. And I would get all these pictures. Beautiful, I like that. Again, if you don't like the form, you can go in here and just by double clicking let's go to my pictures. I want to have a logo in there. Here's my logo, and I can do that for all these tables, save that, create a new preview, and now I have my logo in here. Let's switch on all our objects again. And I can go in here into this project and I can create NC data for the steel shapes. I can export my rebar information to, for instance, the solutions from ASA. I can exchange my information, export my information to an ERP or PPS system. I can do all of that. But the last thing I want to do today is I want to create some 2D drawings. We do that with our detail center. The detail center is taking care about all the detailed drawings, which could be engineering drawings, shop drawings, isometric drawings, whatever. The whole idea of the detail center is the following. I have something, we call it styles, and we have here all our objects. I have my groups, my single parts, I have my concrete objects, I have my steel objects, and I have all my views. Let's start with the views. Now I can say I have here this first portal frame, and I say I assign that to a certain style. I want to clean it up a little bit. I say I want to remove all these styles. And I want to load some. Those here. And I assign this frame to this style. And the second frame, I assign it to a different style. And the next one, maybe to another one and another one, just to show you how it will look like at the end. And I can do the same for my steel objects the same. If I have a look at this one, this is my group number 7, which is here, and I can take those and assign them to this style. So what is a style? A style is defining how the 2D drawing has to look like. And what I can do is I can create now all the 2D drawings automatically. So what it does, it takes the objects, it's taking the style, and it's creating the 2D drawing. So in the style I can define how the objects have to look like line styles, line weights. I can define dimensions, flags, annotations, and then the Detail Center Express, which I'm using now, is creating all these 2D objects. It's taking a drawing frame and will place these 2D objects in the frames, fill out the title block, so I will have the complete 2D drawing done automatically. Okay, let's have a look. Closing here. You see they have turned green. The 2D drawing has been created, and I open that. So this would be my first view. I have my dimensions, I have my annotations, and this would be the second view. You see it's the same drawing, but just by assigning a different style, the 2D result is looking different. And here for my concrete, I can go in here now and I can move the flags around, finishing it up a little bit. For instance, in here, take my text, move it over here. Don't like that one. Can move it over here, and so on. Let's switch back to my 3D model. So what will happen now if I do any modifications? Let's go to this column and be a little bit mean to the system. Let's switch to a different view as well. Let's make this a little bit smaller. I have a closer look here on top. And we have here my web angle connection. This one. Now I'll go to my column, to the properties, and say I want to rotate it by an angle of 5 degrees. What will happen now? It will update all the related connections. The end plate connection from one side, the bracings, everything. So you can see here now that everything has been updated. But what happened to my angle? That angle is not possible anymore. So if I go to my connection, it knows, it determines that an angle is not possible anymore. So it will switch automatically to a banded flat bar. So what happened now to our 2D drawings? Let's open the Detail Center again. Let's have a look at the views, and you would see that a couple of these views have been turned to red. That means they have to be updated. And if we have a look at our group, it has to be updated as well. So I can select those now, update the 2D drawings. So they turned now from red to green again. And if I open the 2D drawing, and if I have a closer look, you see that the column is rotated. Okay, that was fun. I hope you could see how much fun it is to work with ProStructures and how easy it is to use. At this point, I just want to highlight our Bentley eyewear solutions. There is so much cool stuff. And the best of all, it's free for our users. There are solutions to interface between StatPro, StatX, RAM, Building Designer, and even Revit and other solutions. ISM, Integrated Structural Modeling. Check it out on our webpage. There's no time anymore to have a look at Bentley Navigator for a design review, including clash detection, redlining, visualization, time schedule simulation, and much more. And if you want to see your projects on an iPad, no problem. So here a look at my iPad. I've published a few projects, and the projects include not only the model or an iModel, they include JPEGs, they could include PDF documents and whatever. It will save all the views saved in the file, and what we get is a complete 3D model. So I can zoom in, I can rotate, I can have a close look to pretty much everything, and if I select an object, it'll even show me the properties. I can measure and ask for distances. Here are the properties for different objects. And the really fun part is to switch to a really 3D view, and I can use these joystick-like tools where I can fly through the object. And again, if I select any object, I will get all the properties. Whoops, time is flying, and at the end of my presentation I would like to show you one more project where ProStructures has been used. The Tata soda ash plant in Wellington in the UK. The 19th century soda ash plant consists of a 10-story chemical processing building covering 6,000 square meters of floor area. Stockford Project has commissioned the contractor structure survey as part of an ongoing asset management and maintenance strategy. The resulting intelligent 3D model enabled rapid and precise mapping of the entire structure and supported future plant maintenance. The survey team inspected approximately 5,750 individual structural elements and prepared comprehensive documentation which, with every element photographed, assessed, numbered, and recorded on drawings. All secondary steelwork was also inspected, including platforms, walkways, concrete floors, and other load-bearing elements. Survey results were mapped and evaluated for corrosion level and individual components. Stockford Projects converted archival plant drawings into a 3D model and then mapped the degraded sections to create a visual representation for use in development of maintenance plans. More than 10,000 structural elements were modeled in ProSteel and 2,500 metric tons of iron pipe were modeled in AutoCAD. The model was easily modified as site surveys reported as-built conditions, producing an adaptable tool for the client. So thanks a lot again for listening today. I hope you've got a small insight to ProStructures. Don't miss to check out our latest book, For Strat Pro, Analysis and Design for Structures. You can order it directly from our webpage. Again, my name is Gernot Jermin. I'm the product manager for ProStructures.